say a massive, fast-moving visitor to our solar system may have been a probe sent by an advanced alien civilization. Astronomers were excited to discover the interstellar object last year. It was named Oumuamua.
When Oumuamua first passed through our solar system, it sparked endless debate and wonder. A mysterious visitor from the stars, unlike anything we'd ever seen. But now, in a twist no one expected, Oumuamua has returned, and it's brought something with it. The scientific community is in shock, with some researchers overcome with emotion as they grapple with the implications. What could this mean for our understanding of the cosmos? As the details unfold, one thing is certain: the universe just became even more mysterious, and the truth may change everything we thought we knew. The discovery of Oumuamua in 2017. Scientists made a startling breakthrough in October 2017 when a strange object passed through our solar system at high speed. Various telescopes around the world, including the Pan-STARRS facility in Hawaii.
Pan-STARRS is an observatory in Hawaii, and it's scanning large sections of the sky, looking for things that change.
Picked up data indicating that this visitor was not following the usual orbital path seen in local asteroids or comets. As soon as astronomers calculated its trajectory, they realized it had arrived from outside the solar system. This made it the first confirmed interstellar object ever detected within our cosmic neighborhood. Observers in Hawaii named it Oumuamua, a word from the Hawaiian language that translates loosely to scout or messenger from afar. The name captured the sense of awe and mystery surrounding its discovery. Traditional comets and asteroids tend to orbit the sun in recognizable ellipses, whereas Oumuamua's path was clearly hyperbolic.
Oumuamua, as it stands, is a phenomenal discovery and a really important object for astronomers to study and for the public to get excited about. It's okay that it's not aliens.
It was moving too fast for the sun's gravity to capture it, meaning it had come from an unknown location beyond the planets, and that it would leave just as quickly. By the time researchers recognized its significance, Oumuamua was already heading out of view.
I have to admit, when I first heard about it, my first thought is that it was Rama from an Arthur C. Clarke story, Rendezvous with Rama. This is a very elongated spaceship that came from another star.
This limited opportunity forced astronomers to gather data in an urgent, almost frantic manner, using all available telescopes to measure its brightness, speed, and direction. One of the first major clues came from the way its brightness fluctuated. As it tumbled through space, it reflected sunlight in patterns that suggested a highly elongated shape, quite unlike the rounded forms seen in most well-known asteroids. Its discovery came at a moment when astronomers were already refining their surveys of near-Earth objects. The primary aim of such surveys was to identify potential threats to Earth, but the detection of something interstellar was a dream come true for many scientists. They had theorized that objects from other star systems should sometimes drift into ours, yet it had taken decades to find a clear example. Oumuamua arriving in 2017 changed that theoretical guess into a concrete reality. News about this mysterious traveler quickly caught on beyond academic circles. Space agencies, private aerospace companies, and the public all wanted to know what it was and where it had come from. Speculation ranged from it being a bizarre chunk of ice to the possibility of an alien probe. Serious research groups had limited observational time to gather information before it left, which led to a wave of papers. Some proposed that it might be a type of comet missing a visible tail, while others argued there could be more exotic causes for its peculiar motion. During the closing weeks of 2017, many discussions revolved around how to detect interstellar objects earlier, so that a dedicated mission might intercept one before it disappeared. The sense of regret was palpable. If scientists had identified Oumuamua a little sooner, they might have launched a small probe to meet it. Instead, all that could be done was to track its path by telescope. By early 2018, it was too faint for easy observation, leaving astronomers with partial data and a mountain of new questions. Unraveling the characteristics of Oumuamua. Although observation time was short, researchers accumulated enough data to paint a basic portrait of Oumuamua's physical and dynamic traits. One of its most striking features was its estimated shape. Many studies concluded that it was elongated, possibly several times longer than it was wide. Some estimates suggested a length of a few hundred meters and a width of only a few tens of meters. This ratio made it unlike most asteroids that exist in the solar system, which are usually more rounded or irregular chunks. Additionally, it followed a tumbling rotation instead of spinning on a stable axis. Many celestial bodies spin on one main axis over time, which is what astronomers often observe in asteroids and comets. Oumuamua's motion, on the other hand, was more chaotic, flipping in multiple orientations. Some scientists wondered if it had experienced a violent ejection from its home star system, which might have imparted an uneven spin that never settled. Others proposed that collisions with smaller space debris could have knocked it into such a tumble. The surface color also drew interest. Telescopic measurements revealed a reddish or dark hue, suggesting that radiation from cosmic rays or exposure to intense ultraviolet light may have altered whatever materials made up its outer layers. While a reddish crust is not unheard of, many outer solar system objects are red from space weathering. The exact shade of Oumuamua's surface did not match any typical comet or asteroid perfectly. Some astronomers compared it with the surfaces of distant Kuiper Belt objects, which can also appear red in certain light wavelengths. Perhaps the most puzzling aspect was how Oumuamua's motion changed slightly after its closest approach to the Sun. It seemed to accelerate in ways that were not explained by gravity alone. In ordinary comets, such slight deviations occur when ice pockets heat up and release jets of gas. These jets act like small thrusters, nudging the comet off its calculated course. Yet, none of the standard signs of outgassing were detected. This anomaly gave rise to all sorts of speculation about unknown forms of ice, or perhaps a composition that sublimated without producing visible gas. A final curiosity was the absence of any clear coma or tail, features that accompany typical comets when they come near the Sun. If Oumuamua was just a comet from outside the solar system, astronomers had expected at least some trace of water or dust. The fact that there was no sign of it sparked discussions about exotic ices or a crust that sealed in volatile materials. Others, not content with purely natural explanations, pointed out that a well-crafted alien probe might exhibit similar stealthy behavior. Theories from Earth and beyond. What could Oumuamua be? When faced with an object that fits no simple category, researchers develop an array of theories. The initial focus often lay on standard cometary or asteroidal origins. Some scientists proposed that Oumuamua was essentially a frozen comet from a distant star system, perhaps composed of unusual substances like solid hydrogen or molecular nitrogen, which might sublimate without leaving a visible trail. Another subset of experts leaned toward it being an asteroid-like fragment, ejected from its birthplace by gravitational interactions with a giant planet. However, the cometary explanation struggled because of the lack of detectable gas emissions, while the asteroid hypothesis failed to clarify the odd acceleration data. Some astronomers argued that existing instruments might have missed very faint outgassing, but others remained skeptical after repeated checks revealed nothing definitive. A Harvard professor made headlines by suggesting that Oumuamua could be an artificial light sail, a thin, ultralight structure pushed by the sun's radiation. If it were built by an advanced civilization, it might be cruising through space without needing conventional fuel. This theory gained attention because it offered a way to explain the subtle acceleration. Even if most astronomers did not embrace the alien probe idea outright, they acknowledged the need to consider all possibilities when confronted with such an unusual set of observations. Additionally, some people asked if Oumuamua might be a derelict spaceship or a piece of debris from something once engineered. Perhaps it was a silent, ancient probe sent out by an extinct civilization. Others envisioned it as a purely natural object shaped by processes we have never seen up close, if it was forged in a star system quite unlike our own. Oumuamua's return in 2025. Few expected that Oumuamua, or something very similar, might show up again so soon. Yet in 2025, announcements from several observatories indicated that a new fast-moving object, possibly multiple objects, had arrived in the solar system along a path strikingly similar to the one taken by Oumuamua in 2017. News outlets and space enthusiasts quickly labeled this the return of Oumuamua, though it remained unclear if it was the same body or one of the same type. Observers noted that the new arrivals shared characteristics made famous by Oumuamua: elongated shapes, unusual movements, and no obvious signs of comet-like outgassing. Furthermore, calculations suggested that more than one object was present, which surprised everyone. The notion that multiple interstellar travelers arrived together or in quick succession challenged the assumption that such visits were exceedingly rare. Speculation grew that either a fragment of the original visitor had returned, or that there was a small swarm of related interstellar bodies traveling in parallel. Elon Musk and other private sector leaders soon commented, with Musk calling it a major event for space exploration. He urged global cooperation to investigate, emphasizing that ignoring the possibility of an engineered vehicle could be a missed opportunity. Meanwhile, national space agencies mobilized faster than they had in 2017. This time, advanced telescopes around the globe were ready. Projects that had been designed in response to the original Oumuamua sighting now switched into high gear. The public reaction ranged from excitement to concern. Some wondered if this signaled a deliberate approach by unknown forces. Were these objects mere debris from another system, or were they onto a second pass to gather data about our star and any planets that might harbor life? Others pointed out that multiple arrivals could simply arise from a chance alignment of trajectories, with no purposeful intent at all. Regardless of the explanation, astronomers rushed to decode the patterns in the new data. They tracked the motion, checked for subtle accelerations, and searched for signs of gas ejections that could explain any changes in speed. Astronomers also planned to coordinate between space-based assets and ground telescopes, creating a worldwide network of observation. The biggest difference between now and 2017 was readiness. People had spent 8 years preparing for something like this, and they intended to make the most of this unexpected second chance. Scientific and technological responses. After the first Oumuamua visit, many scientists lamented the missed opportunity to study it up close. That event triggered a new wave of planning. Groups like Project Lyra began outlining how to intercept or rendezvous with fast-moving interstellar objects, developing proposals for lightweight probes that could launch quickly if a suitable target appeared. These ideas included advanced propulsion methods, such as solar sails or high-efficiency ion drives, capable of achieving the speeds necessary to catch an object passing through the solar system on a brief visit. By 2025, these plans had advanced significantly. Major space agencies, including NASA, ESA, and their counterparts in Asia, were more prepared to launch a rapid response mission if and when another Oumuamua-like object showed up. Private sector giants, including SpaceX and others, offered their launch capabilities to provide fast turnarounds. Compared to 2017, rocket technology had progressed, and smaller probes could be built more quickly using standardized components. When suspicious objects were identified in 2025, a global effort began. Astronomers used the Vera Rubin Observatory, which had come online in Chile, to perform wide-field scans of the sky almost nightly. Other telescopes, such as ones in Hawaii, the Canary Islands, or operated by private firms, contributed observations to triangulate exact positions and velocities. Meanwhile, mission teams scrambled to finalize designs for an interceptor spacecraft. If the new visitors remained within a reachable range for a long enough period, it might be possible to launch a probe that would at least pass close by. experts recognized that simply flying near one of these interstellar travelers could revolutionize our understanding. A craft equipped with cameras and spectrometers could analyze surface materials, measure outgassing, and verify whether these objects had any artificial components. A successful flyby or rendezvous would settle many of the lingering debates about the original Oumuamua's nature. There was also an increased focus on safety and potential protocols. While most scientists deemed it unlikely that these objects posed a threat, space agencies discussed how to handle unexpected outcomes. What if the probe discovered something truly alien? Would it attempt communication or remain passive? These questions did not have simple answers. For officials, having a plan was better than none at all. This sense of urgency came from the realization that interstellar objects move rapidly and do not remain within easy reach for long. Astronomers could not afford to wait. They needed swift coordination among governments, private groups, and scientific institutions. All these efforts illustrated how one event in 2017 had reshaped the way humanity thinks about interstellar travelers, making 2025 the year when real action became possible. Other related interstellar phenomena. Before Oumuamua, most people assumed that interstellar objects were too rare or distant to be commonplace in our solar system. Yet, a deeper dive into observational data began to change this assumption. In 2014, a meteor that exploded over the Pacific near Papua New Guinea was later identified, through velocity estimates, as possibly interstellar in origin. Then, in 2019, astronomers confirmed a second interstellar visitor named 2I/Borisov, which looked more like a typical comet, complete with a tail and coma. 2I/Borisov reinforced the point that there was more interstellar traffic in our vicinity than once believed. Unlike Oumuamua, Borisov displayed classic cometary activity, which made scientists less puzzled about its composition, mostly water ice and other volatile materials. Its discovery still mattered because it showed that star systems likely eject debris in many forms, some resembling comets and others, like Oumuamua, appearing far stranger. Another area of research focuses on fast radio bursts, FRBs, which are powerful radio signals from distant galaxies. Although no direct link between FRBs and objects like Oumuamua has been established, these bursts underscore how little is known about high-energy or transient phenomena in the universe. Some researchers have theorized that advanced civilizations could use massive energy beams, which might be detected as FRBs, for propulsion or communication. While these ideas remain speculative, they remind astronomers that cosmic surprises can come in many forms. Meanwhile, some scientists have wondered if there might be additional unidentified objects drifting in the solar system, possibly captured in stable orbits or hiding in less monitored regions. There have been proposals to examine areas like the outer solar system in more detail, scanning for artificial structures or capturing faint signals from alien probes. None of these searches have produced definitive results, but the example of Oumuamua has motivated more willingness to look. All these phenomena, unusual meteors, interstellar comets like Borisov, the rare possibility of silent alien craft, paint a picture of a universe teeming with objects passing between star systems. It suggests that the building blocks of planets, and maybe even life, are not strictly locked within one solar environment. Whether shards of rock or lumps of ice come from distant suns, or if some objects carry the imprint of intelligence, remains up for debate.
The arrival of the Oumuamua into our solar system has indeed opened the eyes of many scientists to reality. All over the world, there is an awakening as mankind has become fully aware of the benefits of understanding the universe. But not only that, we are also aware that ignorance has consequences, which no one would like to bear. In the past few decades, so much has been done to plant man's feet on the ground in space exploration. Satellites have been launched and telescopes have been created, alongside rockets with spacecraft going on missions. As this is so much effort being put in, it is easy to think that we are likely prepared for the worst. But this thought had only lasted until Oumuamua tumbled in on us with such speed, shape, and mystery that tells us that we were never prepared for it. But what is Oumuamua? Though no one knew what it was when it first showed up, it soon dawned on scientists what type of objects they were dealing with. It was nothing known to our solar system but an interstellar object. Amazingly, it wasn't discovered by any space telescope, but was caught in sight by Robert Wyrick using the Pan-STARRS-1 telescope in Hawaii on October 19, 2017. It is not strange that this telescope discovered Oumuamua, since the Pan-STARRS-1 is no ordinary telescope. This telescope is equipped with advanced technology, allowing it to scan large portions of the night sky rapidly without having any problems with atmospheric hindrances. When it picked up on Oumuamua, scientists were thrilled and puzzled, as the cosmic wanderer was unlike anything we had seen before. Interestingly, Oumuamua means scout or messenger in Hawaiian, and it lived up to its title. Estimated to be tens of billions of years old, this strange visitor had arrived from outside our solar system, zipping through at an incredible speed of 196,000 miles per hour, 87.3 kilometers per second. Its funny-looking shape and strange trajectory left experts scratching their heads. Was it a comet? An asteroid? Was it an alien spacecraft? Nobody was quite sure. The excitement around Oumuamua's discovery soon spread like wildfire in the scientific community as observatories worldwide joined the hunt, collecting as much data as possible during its brief visit. Before completing its visit, the strange object made an astonishing close approach to the Sun, and yet wasn't sucked in. This caused more questions to arise on what Oumuamua was. After analyzing its trajectory and velocity, scientists concluded that Oumuamua originated from outside our solar system, somewhere in the vicinity of another star. It entered the solar system from above the plane of the planets, swung around the Sun, and then departed on a hyperbolic trajectory which showed that it was headed back into interstellar space. Oumuamua's visit to the solar system was brief, and it moved too quickly to be captured by the Sun's gravity. It made its closest approach to the Sun, perihelion, on September 9, 2017, and then sped away from the solar system. Indeed, the object's peculiar characteristics and unexpected origin has puzzled astronomers ever since. But what characteristics of the Oumuamua leave scientists puzzled? When encountering Oumuamua, the first noteworthy thing is its strange and abnormal lue and shape, different from anything known in our spherical solar system. For the citizens of the Milky Way solar system, it is usual to encounter space objects that are spherical in shape. This is a result of gravity pulling in from various planets within. But the Oumuamua's shape is nothing like that of objects born within this solar system. But how did it look exactly? Based on its brightness variations, Oumuamua seemed to have an elongated and irregularly shaped structure, which is described to be that of a cigar or a pancake, with a length-to-width ratio of about 6:1. This is the very beginning of its uniqueness, as many other mysterious features of the Oumuamua lies underway. So many speculations have erupted already from the mysterious shape of Oumuamua. According to some, it may have been a product of some sort of collision in space, or might be debris from the early stages of the formation of a new planet. With their unique look, the cosmic needle-like objects still had many things that made them very mysterious. Most interestingly, Oumuamua is said to have a single-like shape and a reddish tint, making it a complete space cigar indeed. There are a few theories why Oumuamua might have a red tint. One possibility is that it is made of a carbonaceous material, such as a comet nucleus. Another possibility is that Oumuamua is covered in organic molecules, which can also have a red tint. However, it's also possible that the red tint of Oumuamua is due to something else entirely. For example, it has been suggested that the red tint could be caused by radiation damage from the interstellar medium. In addition to its weird shape attributes, Oumuamua, when sighted, did not move normally, but was rather found to be tumbling through space. This was quite unusual compared to other moving space objects, and scientists tried to explain this in different ways. Some have developed ideas of a binary system, where two objects are found orbiting around each other. To create a tumbling effect, one of these orbiting objects had likely pulled away forcefully from its companion, causing it to tumble through space and into our solar system. Now, the weirdness of Oumuamua continues, as scientists also observed that Oumuamua exhibited a non-gravitational acceleration. After analyzing its trajectory, researchers noticed that it deviated slightly from what would be expected based solely on the gravitational forces exerted by the Sun and the planets. This change in its speed, as well as its deviation from the course of gravity, is known as a non-gravitational acceleration. Now, when objects like Oumuamua pass through the solar system, their motion is influenced by the Sun and the planet's gravitational pull. Because of this, astronomers can predict their trajectories based on these gravitational forces, and the objects should follow predictable paths. However, in the case of Oumuamua, astronomers noticed that its motion deviated slightly from what was expected based upon gravitational forces alone. This deviation suggested the presence of an additional force, hence the term non-gravitational acceleration. The leading explanation for this non-gravitational acceleration was related to outgassing. Here, it is said that Oumuamua approached the Sun. Its surface would have been heated by solar radiation. This heating could cause ice and volatile compounds on its surface to vaporize and turn into gas, which would then be expelled from the object. As gas was ejected in one direction, it acted as a tiny rocket engine, providing a slight thrust in the opposite direction. This thrust resulted in a slight acceleration of Oumuamua, causing the observed deviation from the purely gravitational trajectory. Imagine it like a comet. When a comet gets close to the Sun, the solar heat causes the icy nucleus to vaporize, and the expelled gas and dust create a glowing coma and a tail. Similarly, Oumuamua, although not a comet, could have experienced a mild version of this process, leading to the observed non-gravitational acceleration. While the nature and source of Oumuamua's non-gravitational acceleration may still not be definitively determined, the outgassing hypothesis was one of the most plausible explanations based on the available data. Also drawing attention to the strange Oumuamua was its reflectivity, also known as its albedo, which was known to be quite low. This means that it did not reflect much light. To the amazement of scientists, Oumuamua reflected only 5 to 10% of the light that hit it. This is outstandingly low compared to other space objects' usual reflectivity. As astronomers observed, it exhibited an unusual faint and variable brightness. This characteristic made studying challenging, as its brightness changed rapidly as it tumbled through space. The exact reason for its low reflectivity is not definitely known, but a few possible explanations exist. One possibility is that Oumuamua's surface was made of dark, carbon-rich materials. These materials absorb more light and reflect less, producing a low albedo. Another hypothesis is that Oumuamua could have a thin coating of volatile ice on its surface. As it approached the Sun during its journey, these ices might have sublimated, creating a temporary atmosphere, coma, that obscured the object's true surface characteristics. Prolonged exposure to cosmic rays and solar wind in interstellar space could have caused space weathering on its surface. This process could have darkened the surface, resulting in low reflectivity. The irregular and tumbling motion of Oumuamua might have exposed different areas of its surface to our telescopes at different times, leading to variations in observed brightness. Despite the low reflectivity and the mystery surrounding its exact nature, astronomers could only study Oumuamua briefly before it left our solar system. However, its peculiar properties and limited observation time have led to ongoing debates and discussions about its origin and nature among the scientific community. Among all these numerous debates are the question of what exactly Oumuamua is. Let us look at the first heated debate that arose about the Oumuamua. Is it a comet or an asteroid? While it had been established as an interstellar object, scientists still found it difficult to place their hands on exactly what the Oumuamua was. To answer this question, scientists have come up with so many speculations. Among these speculations was the debate about the Oumuamua either being a comet or an asteroid. This confusing debate has led scientists to closely consider the ready facts. Now, is Oumuamua a comet or an asteroid? Actually, we cannot have the answers if we don't understand what these items are. Comets are icy bodies that develop tails as they approach the sun. This tail is known as a coma, a visible cloud of dust and gas that surrounds the comet's nucleus as they approach the sun. This coma is formed due to the sublimation of volatile materials from the comet's surface. Now, this is what majorly differentiates the Oumuamua from a comet. No visible coma was observed despite its proximity to the sun during its passage through the solar system. As for asteroids, they are mainly rocky objects. According to scientists, Oumuamua is also not an asteroid, and here is why. First, the shape of Oumuamua sets it apart from most known asteroids. This is because its elongated cigar-like shape differs from the more common irregular shapes or rounder appearances of asteroids. Another difference is that asteroids are gravity-bound, while the Oumuamua is not. But if Oumuamua is neither a comet nor an asteroid, what is it? In the end, the confusion about the Oumuamua not being an asteroid or a comet has made some scientists speculate about the possibility of it being an artificial object, such as a probe sent by an extraterrestrial civilization. Avi Loeb, an astrophysicist at Harvard University, is the most prominent proponent of this theory. Loeb and his colleagues have argued that Oumuamua's unusual shape, high speed and acceleration could all be explained if it was a light sail, a type of spacecraft propelled by sunlight. Other scientists who support the alien probe theory include Shmuel Avatel, an astronomer from the Weizmann Institute of Science in Israel, and Alberto Caballero, an astrophysicist at the University of Vigo in Spain. However, most scientists have remained skeptical of the alien probe theory. These scientists have all pointed to the unusual properties of the Oumuamua, such as its elongated shape, high speed and acceleration, as evidence that it is not a natural object. They have also argued that the alien probe theory best explains these properties. In the end, the scientists opposing this notion argue that there are more mundane explanations for Oumuamua's properties, such as the possibility that it is a comet stripped of its volatiles or a natural asteroid elongated by its rotation. So what next? Even though the speed of the Oumuamua makes it unique, it might not be such a good thing for us, as it implies that the Oumuamua might be slipping off the observing eyes of scientists even before there is a chance to understand what it really is. The reality of this has created concerns among scientists, currently doing all they can to gather as much information as possible from the Oumuamua before it finally disappears into the cosmos. One thing that has been instrumental to the information currently being gathered from the Oumuamua is the James Webb Space Telescope. Indeed, the Oumuamua had first been sighted by the Pan-STARRS 1. The James Webb Space Telescope soon took over, proving crucial to the study of the Oumuamua by capturing its precise and clear images. In case you didn't know, the James Webb Space Telescope, JWST, is a space-based observatory and the successor to the Hubble Space Telescope. It was named after James E. Webb, a former NASA administrator, being a joint project between NASA, the European Space Agency ESA, and the Canadian Space Agency CSA, where it was launched on December 25, 2021. The abilities of this telescope will astonish you. First, the telescope is equipped with advanced technology, including a 6.5-meter diameter primary mirror, making it the largest space telescope ever built. Its main advantage is its ability to observe the infrared spectrum, allowing it to see through dust clouds and observe visible light. These features enable JWST to study the formation of stars, galaxies, and planets, even in the early universe.